Welcome to this explainer. Today, we're going to treat the kitchen exactly like a laboratory to solve a universal culinary disaster, the so-called healthy tuna salad. If you've ever tried to make this at home, you know exactly what I'm talking about. But today, we're going to fix it with science.
So, why does yogurt tuna salad usually fail? We've all been there, right? You want to make a healthier choice, so you think, I'll just swap out my traditional mayonnaise for non-fat yogurt. You mix it all up, take a bite, and what do you actually get? A watery, overly tart, kind of chalky mess that completely ruins your lunch.
Well, the core structural problem comes down to basic chemistry. We're trying to take mayonnaise, which is an incredibly rich 80% fat emulsion, and replace it with Greek yogurt, which is sitting at a mere 0 to 5% fat. From a purely structural standpoint, you just can't make a one-to-one swap like that and expect the physics of the dish to remain stable.
To scientifically replicate that classic rich emulsion, we're going to execute a very strict system known as the lipid substitution protocol. We'll diagnose the yogurt-tuna dilemma, move through osmotic control, build an emulsified matrix, lock it all down with architectural integration, and finally, troubleshoot some common defects.
Okay, part 1, the yogurt-tuna dilemma. We really need to understand exactly what goes wrong before we can actually fix it.
The fundamental issue here is moisture and acidity management. If you introduce yogurt directly into your bowl without proper ingredient prep, you instantly trigger vectors of moisture failure. The result? You end up weeping water directly into the dairy matrix, which completely ruins the dish. It just becomes soupy, chalky, and totally unappetizing.
That brings us to phase 1, osmotic control, or, as I like to call it, the drain. The absolutely crucial objective here is ruthlessly eliminating moisture from our two primary vectors, our canned fish and our brined cucumbers. The scientific culprit we're fighting is syneresis, which is basically what happens when excess water causes yogurt to separate and curdle. Yuck. If you don't aggressively dry your ingredients out, the lactic and acetic acids in the pickle brine will clash violently with the yogurt, causing a total structural collapse. We absolutely have to avoid this.
To prevent this weeping, we execute two highly specific physical steps. Step 1 is the press. Grab your water-packed wild-caught tuna, and hey, definitely never use oil pack for this, and aggressively press down with the lid to squeeze out as much water as mechanically possible. Step 2 is the desiccation. Take your finely diced dill pickles, drop them on a paper towel, and physically pat them completely dry.
All right, moving to phase 2, the emulsion. This is where the magic happens, and we build our mayo mimic.
To build this bridge, we combine 1/3 cup of plain Greek yogurt with some highly specific ratios of other ingredients. But listen carefully, you must use organic whole milk Greek yogurt. Never use 0% fat here. That fat content is totally mandatory. To that, we add a tablespoon of organic extra virgin olive oil, a tablespoon of organic Dijon mustard, some fresh chopped dill, parsley or chives, celery seed, salt, and pepper.
Now, you can't just lazily stir this mixture together. Nope. In a separate bowl, you've got to whisk these ingredients vigorously. You have to physically force the chemistry to happen.
So, why does all that vigorous whisking matter? Well, as you agitate the mixture, the mucilage proteins naturally found in the Dijon mustard start acting as a really powerful emulsifier. They literally grab onto the olive oil and bind it straight into the yogurt, creating this thick, glossy suspension that mimics the richness of mayonnaise perfectly. On to phase 3, architectural integration. It's finally time to assemble our biological components. We integrate everything in 3 very deliberate steps. First up is the fold. Pour that beautiful, glossy dressing over your perfectly dry tuna, dry pickles, and your diced red onion or celery. Second is the mix. Fold it gently with a spatula. Don't overmash the tuna here. We definitely want to leave some chunks for textural contrast. And finally, step 3, the rest, where we mandate a cooling period in the refrigerator.
The crucial point here is that mandatory resting window of exactly 15 to 30 minutes in the fridge. Why do we do this? Because it allows those dried tuna proteins, the ones we aggressively pressed earlier, to fully absorb our flavored yogurt matrix. Instead of moisture pooling sadly at the bottom of your bowl, it gets locked deep inside the meat.
Finally, let's talk about fixing common salad defects, because even with a brilliant protocol, you need to know how to troubleshoot using science. So, if you find the salad has a harsh, sour tang, the root cause is lactic acid. If you use 0% fat, there's no lipid coating to buffer those acid receptors on your tongue. The fix? Make sure you're using whole milk yogurt and olive oil.
because fat mathematically slows down the perception of acidity. And what about the soupy salad? You know, the one that looks great on day 1, but is a milky puddle by day 2? The correction there is going back to phase 1 and aggressively drying your wet ingredients. That soupy failure happens because of one relentless enemy, osmosis. The salt in your delicious yogurt dressing is slowly but surely drawing water right out of your pickles and celery over time. If you slack off on phase 1 and leave internal moisture in those vegetables, osmotic weeping is going to completely destroy the structural integrity of your salad.
But hey, armed with the strict lipid substitution protocol, you haven't just made lunch. You've officially conquered the physics of tuna salad. You know how to control osmotic weeping, how to build an emulsified matrix using mucilage proteins, and how to buffer lactic acid with healthy fats. So the real question is, now that you understand the actual chemistry behind a truly optimized, rich, and healthy alternative, will you ever go back to mayonnaise?